friends, lend me your engineers. Welcome back once again. My name is Paul. I'm here with Cameron.
Hello, Paul.
Hi, Cameron. Thank you, everyone, for checking in this week for a very special episode. This was actually almost our last episode.
We almost had an incident.
Well, we did have an incident. It was almost a disaster, but
That's a better.
We'll get into that in just a minute. Today on the show, we have a very special, interesting, experimental podcast. We actually took our podcast into the BRaIN lab, where Dr. Helen Huang was being interviewed by the Nightly News, UCF Nightly News, Nightly with a K, not NBC.
Yeah, Lester Holtz was not there.
No, Lester Holt did not make the trip for the local Nicholson School of Communications.
But we're hoping eventually to get to that
In the
point.
future, I think that's where we're heading. So the Dr. Huang was being interviewed, so we thought we do sort of like an Inception where it's a show within a show. So we recorded the
Audio.
well, yes, we recorded the audio of her being interviewed by someone else.
Yes.
So it's a little different, but it made for an interesting show. We got over an hour of footage, and we were able to turn that into a show, which is what you are going to hear today. So without further ado, here is the very exciting BRaIN
Show within a show.
Show within a show within a show. So how do you feel after your first interview on camera?
It was nice to be able to talk to a person versus looking into the camera, even though every once in a while I looked into the camera because that's what I had to do previously. So then I was like, no, just like a crystal. It'll be easier that way. So little baby steps, right?
Sure.
So it wasn't too bad. They seem very welcoming.
Thank you.
So right now they're going to prepare the EEG cap. And we're just going to put one strip in just for the sake of demonstration purposes.
Oh, do you want to get the tag?
I've actually done this.
In another lab? Yep.
Yeah.
Because there's other labs here at UCF that, they use EEG or they use EMG or they have motion capture. Nobody else has a treadmill like this. But there's definitely nobody else who's integrating all these things together.
Yes.
Okay.
So we have a wet system, which means that we have to put some gel. And the gel acts as a bridge between the electrode tip, recording electrode tip, and the scalp. You hear electrode and people are like, are you zapping my brain? I'm not. Other people are, but I'm not. We're just trying to record your brain activity. So you have to put a little bit of gel in each well, and then they'll place the electrodes. And we have these little tiny electrodes. This is part of an active system. Active meaning that there's a little amplifier that's really close to where we're recording the signal from, and that gives you a better signal to noise ratio.
Imagine how much shorter it'll be without digitizing.
Yeah, so there's another part to our preparation for our actual research, which is we have a system to digitize the location of all the electrodes on someone's head, because everybody's head is a slightly different shape, which means that the electrodes will be located in slightly different places. And then part of what we're doing is we use these algorithms to try to find where in the brain the electrical activity is originating from, and we can get a better localization, we can identify the brain areas more accurately if we get more subject specific information instead of using a template for everybody. Just everybody's brain's a little bit different. So something we're adding that we haven't actually started yet is we'll be getting subject specific MRIs, so magnetic resonance images. And we're getting that from the Orlando Health Radiology group. They're going to help us get scans of everybody's heads, everybody's brains. So then I'll have subject-specific MRIs as well. People will probably think that's pretty cool too.
That sounds really cool.
It's just a lot more work for us in terms of analyzing all the data.
Yeah.
Because now it's now we have something subject specific and you have to, set up your code.
To record the specific
to
areas.
align it all, and using a template's way faster, but not as accurate. We want to do the most advanced techniques, which usually are also require more work. Correct. So
Understandable.
really fortunate that the university and the department gave me the resources to be able to build this lab. And be able to do all these things at the same time. Because as other people have said, oh, your lab must be pretty expensive. It's relatively expensive. I think I did a pretty good job setting it up for not being excessively expensive. But equipment's expensive in general.
Yeah, sure.
Did you have an idea of like the type of equipment that you wanted to purchase?
Yeah, for my previous position, I came from a very well-funded lab where I did my PhD, and I was a research scientist. My advisor was very successful getting funding, and we kind of had all the, I say toys, but a lot of different techniques and equipment available to us. And so of course I want to build a lab just as impressive, but with a lot less money until I get more funding myself.
And the wires they're currently connecting now, those are the ones that...
They're going to record from the BRaIN, yep.
Okay.
So that's for the EEG system. So I have this is a 128 channel system. So there's 128 electrodes that we would normally prep on a person. As you can imagine, doing anything 128 times just takes time. So you're like, oh, it doesn't seem like it would take that long to put in some gel and then place the electrode. But then you're just like, okay, on time 128, you're just like, okay, this is taking longer than I thought.
How long does it usually take to set up a subject completely?
Once we are able to do it smoothly, they should be able to do everything from putting the markers on the person, putting all the EMG on the muscles, prepping the cap, and digitizing the EEG electrode locations. They should do that in like an hour to an hour and let's say 15 minutes. They don't believe me at this time because they haven't been able to do it yet, but they will. Because in my previous lab, like I said, I came from a very well-funded lab. You had 256 channel cap. So just imagine twice as many. And we are able to prep someone in like an hour and 15 minutes as well. Because we usually have multiple people. So like here we have 2 people. We might have 3 people prepping a participant at any time. So today they're doing a whole body marker set.
The first time we did it with Alejandro and Kevin, it was amazing to see the whole body on the skeleton.
Screen.
Yeah.
Yeah, so since I'm mostly looking at walking, like we usually just do a lower limb marker set, so you just see like the simulation of the legs. And I actually have not seen the whole body
It's pretty fun.
marker set before. So this is new for me. This is what I mean. The students are the ones who do most of the work, right? Professors, we write the proposals to get the money so we can support the student. So hopefully we can keep them happy, do good research, take them to conferences. Like Syed and I, well, actually Syed, Jennifer, and I were leaving on Friday to go to a conference. So,
Where are you all headed?
Washington, D.C. for the Society for Neuroscience meeting. It is a gigantic meeting.
Yes,
There's about probably 35,000 people. It's crazy. So everybody's like, oh, it seems so big. And it is gigantic. But then it's kind of like really small because you end up just hanging out with other people who do your research. So then it doesn't seem so gigantic. And what's nice is because it is so large, you get to see a lot of people that you may not otherwise see. So that's fun.
Okay, so can you just close your eyes? So these are
They're called alpha waves.
Alpha waves.
So when she closes her eyes, we can see around like a 10 hertz wave from
Open
those
your
electrodes.
eyes.
And then it goes away when she opens her eyes.
Those.
So when she blinks, does it go several times?
Yeah, you can try blinking. Since these electrodes are on the back of her head, we may not see them as well. So take some blinks, like,
Oh yeah, you see more of it.
Yeah. Okay. clench
and
your
then
jaws.
she clenches her jaw. So when she clenches her jaw, we just get large signal, and that's from the electrical activity generated by your muscles. Should we put her up on the treadmill?
Yeah. Can we check also?
Oh, you want to check the EMG? Okay, so then,
Can I stand up?
sure.
Sure. Okay.
Oh wait, I was about to say. There's
Yeah, go ahead.
Greg. We used to have people. We used to put the equipment into a backpack and have people sort of carry the equipment. And then I was like, oh, my mother would probably not appreciate this. So then I was like, oh, okay, we should come up with a different system.
So,
At least you had
go
great-
to your-
Great
Yeah.
students, right? So this is the
Up
EMG.
and get her moving.
your toes.
So this is the electromyography, the EMG.
Toes.
So you can see when she goes up on her toes, we get the muscle activity from the muscles on the back, like the calf muscles, as people would probably know them as. And then when she pulls her toes up, we get the muscle activity from the muscle in the front, responsible for pulling up your toes.
So we're good.
All right, we're good. So we're gonna put her on the treadmill,
Okay.
then create this whole body motion capture that I've never seen before in my lab. Seen it before, just not in my lab. They're treating me to something new today. So we had to come up with this whole sort of like setup so that we can try to get the best data. Oh,
Okay.
new edition. You didn't see this before.
Can you explain what's happening right now?
So, we're gonna move to a new method of collecting the data where we use two different systems. So we're gonna have one system that records the electrical signals on the scalp from the brain, but we're also gonna have another system that records signals from a reference layer. So that would just be the noise and the movement artifact. But it requires having two independent systems, which means twice as much equipment, which means nobody wants to carry all of that. So we had to come up with a different way. So right now, I had them install essentially like a little system where we can hoist the bag over a person. So now they're not having to carry the weight of the equipment. So that's what Jinfeng is preparing right now. And then we have a little like tie down, like, like you might see on a boat over by the window. And we have a cable, so we just hoist it up.
So it's like in theater where they raise up the sandbags.
I guess. I didn't know they do that in the theater. I don't know anything about the theater.
Yeah.
What you just talked about last time, Shakespeare, right?
Yeah, but that was me being in a class listening to like a lot of opera on CDs at the really cool music library.
Speaking of music,
Yeah. Use sandbags to raise and lower the curtains.
I know. I just said that.
I didn't know that.
I know. I mean, you. I would assume that.
Yes.
You know that.
Everybody learns on this show.
I've seen a theater once or twice.
I've seen a theater.
I've seen one.
I'm a proper gentleman. I go to the theater.
There's the safety harness that we discussed in the previous podcast.
I know we promised that Cameron would be hooked into this, but we'll have to save that for a later show.
He didn't seem super excited actually about it.
What? What? I was super excited.
You ruined it, Cameron. You weren't excited
That's
enough.
what I was. I ruined it because I wasn't excited enough. No, I would be super excited and thrilled.
Well, we will have a lot of studies, upcoming studies.
Just let me know.
Like, it's all on my board
I see.
over there. projects that are funded on the left, projects that I would like to propose on the right. And on the left, that is, that's over 100 subjects we need to collect. So a lot of data collections are in the student's future.
We have one.
A lot of data will be generated. So much data that like they could not use their laptop because it will crash their laptop, and then they'll be mad at me. Be like, I can't do anything on my laptop. Yeah.
So currently our subject is on top of the treadmill, being hooked in to all the apparatus for safety. And then once everybody is ready, what will happen next?
We have to create the model in the motion capture system, and then they'll start the treadmill and have her walk. And if we just keep all the systems running, you'll be able to see all of the data
Being collected.
being collected. And then there's my stepper back there that doesn't get as much love, but like I said, was actually the novel part of my proposal. And that is my PhD project. My advisor, Dan Ferris, I always say Dan Ferris because I usually just call him Dan, and then I'm like, oh wait, I should probably say like Dr. Ferris. He let me take it with me here, so I'm very fortunate that he allowed me to just take it, and I've been able to just keep using it for research. So that was really helpful for him to let me take it.
Thanks, Dan.
Yes, thanks.
Dr. Ferris.
I got my... Oh, you're just trying to cover the electrodes in the back.
Yeah. Okay. Okay, just stand. Can step away.
So how many how many markers should we see?
39.
We see 38.
And
Which one are we missing?
no, we have that. Should have 39. And 3.
Is it one of
Oh. Or maybe this one. Yeah.
Yeah, it's one of the ones in the back. I had a lot of fun setting up my lab, actually. It was a challenge. It was like, okay, here's how much money I have. How much should I spend? Like how much of a risk taker am I? Because the riskiness is obviously the more that I spent up front. It means that I would have to get funding sooner so that I could continue doing my activities. So I took a risk on my ability to get funding, and it sort of paid off. So
Would you like to stand in T position? Can you stand in T position?
I only see 38 markers. What am I don't even missing.
So 3.
We're still missing a marker.
Yeah. So it's not here.
Did you place 39 markers? You know the one you can't see is the one on is this one, like right in the back. Turn this one around. You should have one right there. Turn around. Turn around. That one.
This one. Okay.
Yeah, because you're covering it.
Okay. Yeah.
So like you need to.
Oh, there's not even one there.
Oh, you didn't even put it on.
Yeah.
My
See?
hair tie is on the table.
Do it.
Get some tapes.
Like I needed a lab space that had a high ceiling, so they had to actually raise this little pocket here for me. So that's up to 10 foot 9 inches high.
Did your neighbors upstairs lose 10 feet of their office?
No, because it's a drop ceiling, so there's still stuff above. And I wanted to be on the ground floor, and I wanted to have access to a parking lot, because if I'm testing older adults, then I don't want them to have to walk half a mile to get to the lab, or I don't want to have to like rent out the golf cart to go get them in the rain.
Right.
Okay, there you go. Now there's 39.
Stand still in T position, and I create a skeleton on 3, 2, 1. Okay.
Okay.
And then
I think I'll remove like.
yeah, would you like to match in place?
Wait, she has to march in place.
And you can stop. Okay. And go back.
Okay.
Okay, you're fine now.
So now you can see on the screen there's a simulation of her body. So as she moves, like she's waving, then we see the little body avatar, I guess, also wave.
I love that ride.
You like?
At Magic or Animal Kingdom. Have you been on that yet?
No, I have not been to Disney World since I got here. Should I go?
It's pretty cool.
Okay.
Yes. What we were doing when we first did this, we were like doing the Tekken fighting stance.
That's what a lot of participants who've never seen it before do. They're like, "Oh my god, that's me!" and they start like dancing and just like goofing around. They're like, "That's so cool." It's actually kind of fun. Like people who've never seen any of this, when we put it on them, and then they see when they contract their muscle, we get the signal on the screen. They're just like, "Oh, that's so cool." So it's, I hope they have fun when they come in. All right. So now Jim Feng is setting up the treadmill. So like I said, it's not like your typical treadmill at the gym where you just have like a few buttons. There's like a whole program that's involved with getting the treadmill to run, operate safely.
There's a large red button in front of him. Is that some sort of kill switch?
That is, yes, an operator panel that allows us to, stop the treadmill in case anything might happen. There's also some safety mechanisms on the treadmill itself. There's like sensors, so they refer to it as a light gate, which is basically like an infrared sensor that when you block it, right, it breaks the connection. So then it will be like, okay, someone must have fallen, so it'll stop. So there's 3 of those on the treadmill, and the operator has the ability to stop the treadmill if we need to suddenly. There's a safety harness in case people fall. There's the handrails. So I think one of the things that maybe is the most disorienting thing about it is you can see it's like elevated off the ground. So it's like 20 inches above the ground. So you're not used to that, right? Your treadmills at the gym are not going to be that high off the ground. That was another reason to raise the ceiling, because otherwise you can imagine like your head is like right next to the ceiling and be like, oh, this is not normal.
Okay, so what gonna we do first?
I don't know. What do you guys want to see? What would be fun?
What can you show us?
What can we show them?
Okay,
Maybe, well, I don't think I want to show the perturbations because then, like, people, if they have an idea of what they might experience, then you might have a form of plan ahead of time. So, but we can show, like, incline and decline and just the treadmill going side to side, just to show that we can do that. And then everybody always is like, wait, you can walk if one belt's going faster than the other? I'm like, yes. So people like to see that too.
Opposite directions.
Oh yeah, we could do 1 foot going forward and 1 foot going backwards. People are just
You
like,
can start with the simple if you want.
so just start with the simple.
You put the camera.
no, that's okay.
Probably. Okay. Yeah, as long as we're not moving the treadmill, are we? Because if she puts her camera there, I don't want it to move, and then they.
Like while it pitched, it will move.
Right,
Way it would
so-
move.
So,
But for now,
We'll start.
just leave
you
it
are-
level.
If you want to like do that,
like
just-
let us know
yeah.
so that she can move the camera.
Right, so I don't
Right now,
engage
just leave
first.
level.
Yeah, just
Level.
level working with 1 meter per second speed. Start the treadmill on 3, 2, 1.
See on the screen, we're capturing her movements, her body movements, and then if you look on this screen over here, you can see her muscle activity and then the brain waves. So this is like the movement artifact that we're talking about. So there's like this little spike that is really more related to her foot contacting the ground versus being a signal from her brain. And you can imagine it gets worse the faster you walk, right? So a lot of people who do this sort of research, they just have the participants walk very slowly, because if you walk really slowly, then you don't have the artifact. But then you can make the argument, well, is that really walking? So, but then they say, oh, we're looking at people with stroke, and they walk really slowly, so...
You want to go to the split belt?
Okay.
Okay, so what are we doing now? We're gonna have one belt go faster than the other?
And before that, I need to stop first.
Okay.
I'll stop the treadmill on 3, 2, 1.
You're stopping it, in case you couldn't hear him. So I guess set it so that one belt's at like half a meter and the other one's at 1.5. The traditional split belt paradigm. Then we'll see how fast Amy walks. So this is part of adaptation. So you can imagine at first she'll be very asymmetric, and then as she gets used to it, it will look like she's walking more symmetrically. So let's see if Amy can.
Okay, we're gonna start split belt working with left belt speed 0.5, right belt speed 1.5, and gonna start on 3, 2, 1.
It looks like they're going the same speed. Nope, no, there it is. Amy's like, no. Whoa.
Good.
Yeah. That's a big difference. So some people say it's like skateboarding, but
Yeah.
so right now she's still getting used to it. So you would have people walk for 5 minutes or something, and by the end of the 5 minutes, it would look like they're walking relatively symmetrically. And people are using this sort of paradigm for rehabilitation for individuals with stroke.
And that's where everything went wrong. No, actually, that's where one SD card ended and it went to the next one. And remember, there's a great, big, beautiful tomorrow shining at the end of every day. And tomorrow is...
Just dream way.
Yay.
Thanks for the save, Paul.
Yay. All right. Have a good week, everybody. We'll see you next week on Lend Me Your Engineers.